Hi, this is Mr. Patrick Ang, and this is the second video for energy and work done. Now, energy is a concept that you have already learned in primary school, so it's nothing new. We will still go through it so that you can remember what you have learned. So in science, energy is the ability to do work. Okay, we remember from the previous lesson, work done is equals to force times the distance traveled in the direction of the force. So all living things need energy, and energy has the same unit as work done, which is joule, and the letter is capital J. So we know that non-living things also need energy to function. Okay. Now there are different forms of energy which you have already learned, but let's go through. The first one you need to know is potential energy. Potential energy is another word for stored energy. Okay, so in this under potential energy, we classify there are three types of potential energy. The first type is chemical potential energy, and this is stored in fuels such as petrol and food. Okay, and also it can be stored in things like batteries as well. Now I have this video of a battery commercial by Duracell. Okay, it's in 1983. Just take a while to enjoy it.
Duracell batteries can make fun times last a lot longer. If you put Duracell batteries into one toy and ordinary carbon batteries into all the others, you'd find that after just a few hours of continuous use, the ordinary batteries give up. But Duracell batteries keep going. In fact, depending on the toy, Duracell can last 2, 3, up to 6 times longer. Duracell. The copper top battery. No ordinary battery looks like it, no ordinary battery lasts like it.
So this was an advertisement by Duracell. And then when Energizer saw it, Energizer came out with another commercial to counter that. So this is just for your amusement.
For years, you've seen some commercials where one battery company's toys outlast the other toys. So you may have assumed their battery outlasts even Energizer batteries. Fact is, Energizer was never invited to their playoffs. And today's Energizer won't be invited either. Why? Because no battery lasts longer than Energizer. So now you know. A word to the wise. Energize.
Okay, so it's trying to say that Energizer was not invited. So Energizer is actually can last longer. Well, that's up to you to decide. Alright, so now let's go back to chemical potential energy. Okay, the second kind of potential energy is known as gravitational potential energy. It happens, an object has gravitational potential energy just because it is at a higher ground. Okay, so as long as it is higher, generally it will have more potential energy, more gravitational potential energy compared to the same item at a lower position. Okay, so this is what gravitational potential energy is about. Got to do with height. Now the third one is elastic potential energy. This can happen in things that can be stretched or compressed like a spring. So it can be stored in the spring until being released. So we have three kinds of potential energy: chemical potential energy, gravitational potential energy, and elastic potential energy. Now the next thing kind of energy you need to know is kinetic energy. It is energy that is around because of motion. So as long as an object is moving, it has kinetic energy. So for example, a bird flying in the air, a girl walking, or a car speeding down the road, all of these have kinetic energy. And you also need to know that if an object travels faster, that means the speed is greater, there is more kinetic energy. Alright? So that is kinetic energy. The next thing you need to know is heat or heat energy. So heat is the energy that flows from the region of higher temperature to one of lower temperature. Okay, you will learn more of this in the next chapter when we talk about energy, thermal energy transfer. Okay, so heat flows from things that are hot to actually things that are colder. So here we know that the sun is an important source of heat energy, and heat is also used for cooking. So heat is a very useful form of energy, even though it can be a negative energy at times. Okay, the next one is light. So light is energy that enables us to see, and Without light, we actually cannot see, we will not be able, yeah. So that's the main idea. Okay, so light is a form of energy. The next is sound. So sound happens when when objects actually vibrate. So it allows us to communicate and enjoy music. Okay, sometimes it's also used as a warning. The next is electricity or electrical energy. So electrical energy is the result of the flow of electricity. And it's useful because we can actually transport it around, not like other forms of energy. Electrical energy, we can actually keep it and we can actually transport it from one house to another, from the power station to your house. So it's very useful because from there in your house, you can then convert it to other forms of energy that you want. Lastly is nuclear energy. It is stored in the nuclei of atoms and is found in power plants. And also can be found in the sun as well, actually. The sun is also one big, there's a lot of atoms inside, and because of the atoms and the nuclear fusion that happens, that's why it actually produces energy for us. Okay, the next thing to know is conversion of energy, something probably you have learned, but we're just going to go through. So photosynthesis is an example. It takes energy from the sun, light energy, and it converts light energy into chemical potential energy, so it will be stored. Another example is like an archer releasing his bow. So when the string of the bow is actually being pulled, so it is actually elastic potential energy. So when you release it, it actually converts to kinetic energy and cause the arrow to fly forward. Next is a moving car. So if a moving car, it has fuel. So when you burn the petrol and burn the fuel, it actually converts chemical potential energy stored in the fuel into kinetic energy to actually run the engine. So the engine can actually move. Now, the engine actually, if you want to know, the engine actually, when it's moving, it actually moves, it actually causes this thing called the alternator to move. And this alternator actually generates electricity. So this electricity is then used to power all your electrical appliances in the car, like your radio, your automatic windscreen. So that's where you get your lights and heat and sound energy from actually. Okay, so you can try this yourself. There are 3 examples here. You can pause the video and try it now. Alright, so these are the answers. So when the roller coaster is actually at its highest part, the gravitational potential energy is the highest. That's why when it comes down, all this energy is converted to kinetic. Okay, electric toaster converts electrical energy to heat energy. The MRT train that we usually take converts electrical energy to kinetic energy. The next thing to know is the conservation of energy. You need to take note, this is different from what we learned just now. What we learned just now is conversion. This is conservation. So what is the difference? Okay, conservation of energy is actually talking about how the amount of energy is kept the same. Now what do I mean? So there's this principle that says that energy cannot be created or destroyed. You cannot have energy appear out of nowhere or disappear. Okay, it doesn't become more and more. In fact, all the energy that is around has always been around. It just depends on what form it is in. So in this case, we know that energy can be converted from one form to another, but the total amount of energy in a system cannot increase or decrease. It will remain the same. Okay, so let's consider a swing for example. So a swing at the left side when it's the highest, it has only gravitational potential energy because of its height. But when it swings down, as it's swinging down from A to B, some of the energy is converted, some of the gravitational potential energy is actually converted to kinetic energy. So it's going faster and faster, but it's losing height. That's why energy is being converted. So as it reaches its lowest point, here, B, all the gravitational potential energy has been converted to kinetic energy. So at this point, it is moving the fastest. Okay, so after this point, as it goes up, you realize that all the kinetic energy starts to convert back to potential energy. And as it goes up, it slows down, it becomes higher and higher. So potential energy comes to kinetic, go up, become potential. So no energy is actually lost through the process unless it's because of friction or air resistance. If not, generally in a system, if there's no friction, all energy is conserved. There is no loss of energy. Okay, so to better illustrate that point, I have this applet here. So this guy is on a skateboard. I'm gonna put him here and I'm gonna let him start swinging around. And yeah, okay, he's swinging fine. I'm gonna open this bar chart. And from this bar chart, you can see that the total energy stays the same no matter what. Okay, assuming that there's no friction. So let's convert to slow-mo now. And let it go all the way up. Right, so we're gonna stop here, pause here, and you can see that at this point is the highest point that you can go, where I just now released him. This is the highest potential energy. So all the energy it has is potential. Now when I let go and he starts coming down, you realize that the kinetic energy is increasing while the potential energy is decreasing. And at the same time, you realize that total energy stays the same. So let it go all the way down. Now at the lowest point, you will see that the kinetic energy is now the greatest, while the potential energy is now the lowest. So all the potential energy has been converted to kinetic energy. No energy is lost. So as he moves up, he slows down. And as he slows down, you realize that all the kinetic energy is converted back to potential energy. So this is just to help you to understand better how does the energy changes as the person on skateboard moves up and down. Okay, so remember, energy cannot be created or destroyed. It can only be transformed from one form to another. Okay, so that is the end of this video. Hope you learned something from it. Okay, thank you.